That's right. It is. We're going up 1 and over 4. So m is 1/4. Now, to write the equation of the line, it's the easiest thing you can do. Well, almost the easiest thing you can do. 2 plus 2 is pretty easy too. So all we have to do is put these values in where the m and the b are, and we're done. So y equals 1/4 x. Do I really need to put plus 0? I don't need to, but I could, and it wouldn't be wrong. Okay? I'll put it there, but we wouldn't normally write that in math. Y equals 0x minus 4? What are you talking about?
No, for the fun.
I'm not there yet. You're ahead of me. Okay. Okay, just, Jonathan, you're going to have to be patient. I'll get there. Okay. Let's look at number 23. So, the m and the b. The b is probably the first thing you want to look at. In this case, it's 3. Good. And the slope, I've got to pick 2 points on the line. Oh my gosh, I've got to come all the way down here to find another intersection. So this slope is going to be up and over how much?
5.
Up 5?
5 over 2.
Over 2, correct. 5 over 2. Count the spaces between. 1, 2, 3, 4, 5, and 1, 2. So y equals 5 over 2. Don't change that. Unless you can reduce it, leave it improper. We want that. X plus 3. All right. So when we're writing an equation in this y equals mx plus b form, we know the slope, the rate of change, and we know the y-intercept. Let's look at that front page now. And see if we can write this equation. Here they're telling us the slope and the y-intercept. So slope-intercept form is going to be y equals mx plus b. And this is the easiest graph making equation that there is. I can't think of anything easier. We don't very often get them this easy. Not when they're giving us the information. So this is going to be y equals 0x minus 4. I think the other day I told you what part students tend to like to miss. The x. Don't forget the x. Right? It's not the slope. It's how many times you do the slope.
What's slope-intercept again?
Slope-intercept is this form of the equation, where we have a slope and a y-intercept. Now, could I simplify that? Yes?
So if you graph that, wouldn't it just be like a straight line on the y-axis?
No, actually it wouldn't. It would look like this. So here's my x and here's my y. Okay? And if I simplify this, I can just say y equals negative 4. You with me on that? So where does y equal negative 4? Like down here, right? Where else does y equal negative 4? You got it. It's horizontal. Yeah, this one's horizontal. So it would graph like this. Yep. But they're all straight lines. Unless it has an exponent, then it's a curve. Okay? I knew what you meant, though. So on number 3, they are wanting us to take an equation that's in sort of a modified version of point slope, and they want us to change it into slope-intercept. To do that, what we do is we solve for y. So the first thing I want to do on number 3 is I want to distribute the negative 4. So I'm multiplying negative 4 times both of those terms. The thing that I see students miss out on distributing is they multiply like the -4 times the x, but then they forget the -1. So you got to make sure you multiply times everything in the parentheses. So this is going to be y plus 2 equals -4x, and -4 times -1 would be plus 4, right? And then the only thing I have left to get the y by itself is to subtract 2 from both sides. And then that's in our slope-intercept form, easy to graph. So, we good? Shall we do another? Let's do one with a fraction. How about we do number 5? Because I know what happens when we have fractions. Some of you get the cross out from around your neck and you hold it out, and you get out your wooden stake and your gun with the silver bullets, right? Okay? Right? Okay? Yeah, not necessary. We're going to distribute the 5/4. Don't be too scared. So y minus 2 equals 5/4 times x is just 5/4 x. 5/4 times -4, that might be a little scarier. I'm going to take the -4 and I'm going to write it as -4 over 1. I'm going to make it a fraction. Yes?
Wouldn't you just like multiply across?
That's exactly what you do with fractions. So you multiply across. So this is going to become -20 over 4, right? And 4 goes into -20 how many times? 5. -5, right? So this is -5. But there's a shortcut to it. These guys cancel. Yes, sir.
I was going to say, since 5/4, you can just add 25% to the -4. That makes it, yeah.
Cody, you have good math sense. You have very good math sense. Keep that up. Good job. Yeah, it's true. So here's how he was thinking of it, I think. Let me get a piece of paper out here and show you what he had in mind. Cody saw that 5/4 was the same as like $1.25. Right? That was the idea. And he's multiplying $1.25 times 4. Well, 4 times $1 is $4. How much? What's 4/4? Another $1. That's how he saw that, right? More or less.
But yeah.
Except maybe with a quarter instead of the 20.25.
Well, I didn't see with like money or anything. I just saw like the percentages.
Yeah. Yeah. Okay. Cool. So that's totally a good way to think about that. Right. So I can't fault that kind of thinking at all. But what I really want you to see is that these 4's cancel. That's a nice, quick, simple thing. And we're left with just -5. Okay, so now the last thing we have to do is just add 2. There we go. All right, now we're going to get into the writing of the equations. That's just simplifying, and the other one is writing an equation, but it's pretty simple. Let's look at number 9. Actually, no, let's look at number 10. So if I know a slope of a line, and I know some point on the line, then I can find the y-intercept, right? Wouldn't I be able to like graph it and find it somewhere? We can also do it mathematically, and that's what the slope-intercept formula does. So the slope-intercept formula, better write this down. We've already written it down, I know before, but the more you write it, the more likely you are to remember it. Y equals m times x minus x1 plus y1. And if you have it on your paper, then you have it too, right? You don't have to go looking for it. So we're going to look at number 10. The slope is the m. The negative 5 and the negative 4, that's our x1 and y1, right? X is before y's. Slope y is on top of x's. Now, I'm going to take and plug those bits into this equation. So we're going to say y equals 8/5 times x minus a negative 5. The way I think of this is that it changes the sign of the x. Exactly. It's going to change it into a plus because you got a double negative. And then the negative 4, since there's a plus here, that doesn't change. That's just minus 4. You can write that as plus a negative or minus. Either way works. And that's it. Wait a minute. I take it back. It says slope-intercept form. I thought we were done. We're not done. So now we have to simplify it. So 8/5 times x and 8/5 times 5. What's going to happen to these 5s? They are going to cancel. 5 and 5 cancel, so it's going to be plus 8 minus 4. So my final answer is going to be y equals 8/5 x plus 4. That's the slope-intercept form. Now, sadly, this doesn't cancel all the time, but here's what's going on. 8 times 5 divided by 5. And 5 divided by 5 is 1. So what we really end up with that canceling is we end up with 8 times 5 over 5, and these guys cancel. And so I'm just left with 8. Okay? Another way to look at why that cancels. Okay? All right. My bet is that most of these will cancel something. So let's move into the back of the first page here. Number 14, that's going to be a tricky one. I'd be curious to see how you do with that without me giving you some pointers. Okay, what if we have 2 points and we want an equation of the line? Let's look at number 15. I've got 2 points. I need an equation, so I have to go through 3 formulas to get there. John?
I could do like x2 minus x1 and y2 minus
Which one is on top?
the y
The
on
y's.
top and
Good.
x plus y.
But I think I showed you a way that you could kind of do that, maybe a little bit more in your head, numeric, like on a number line kind of thought. Allison?
It's like the x1 and x2 are you
Yeah. Start with the y's. The y's, the second numbers would go on top, right? So on a number line, going from -5 to -1, is that positive or negative? That's positive, right? We're getting bigger. And how much bigger? 4. Yeah. So this is 4. And I'm going from 3 to -3. Is that positive or negative? Negative. And how much? 6. Good. So my slope, my m, is 4 over -6. Could I reduce that a little bit? You bet. In fact, if you don't know how to reduce, you should. But if you don't, so what I'm doing is I'm looking at this and I'm going, okay, I can divide both of these by 2 to get 2 over -3 or -2/3. But let me show you what you can do on the calculator. If you're struggling with fractions, these graphing calculators are not my favorite calculators to work with fractions, but they'll do it. They work just fine. I just think they're a little harder to use than some of the others. If you go to math, and you go over to fraction, and we choose this top one, and let's say I want to put in, what was that, 4 over -6? I put a 4 and a -6 in. I know that's awful small. You can't really see it all that well. If I hit enter, the calculator is going to give me the lowest possible fraction or whole number for that. It reduces it. So there's my -2/3. Okay. So if you're struggling with that, you can force the calculator to do it. I would rather you give it a try yourself though. So now that I know a slope, and I know 2 points, but I only need one, I get to pick the one that I think is friendliest looking. Which one do you guys like better? The 3, -5? Okay, let's take that one. So this is going to be our x1, y1. This is our m. And so we go into slope intercept. So we're going to use y equals m times x minus x1 plus y1. So that's going to be y equals 2/3 negative times x minus 3 minus 5. Okay? But the question is asking for point slope. So I'm going to simplify that to get it to point slope form. So I'm going to distribute the -2/3. What's going to happen to the 3's? They are going to cancel. 2/3 of 3 is just -2 minus 5. Wait a minute. Is that negative or positive?
Positive, because it's a negative versus a negative.
You got it. Thank you. I made a critical error there. So y equals -2/3 x minus 3. And that is now in y equals mx plus b form. And why do we like that? Because it's easy, right? It's easy to graph, it's easy to work with. It may not necessarily be easy to get to, but it's not that bad, right? Okay. So I'm going to cut you guys loose on this. I'm going to come around and help out once I take roll.